Hello everybody. Let us discuss today the determinant. Now the importance of determinant is very much in inversion of a matrix. So when we are to invert a matrix to solve some simultaneous equations, then determinant is important. Now what is determinant? So it is a scalar quantity of a square matrix. Suppose the square matrix is A, and determinant of A is represented as like this. But if we put the hook, it will be matrix, but if you do not put the hook, it is the determinant. So this quantity is obtained by summing various products of the elements of A. So an determinant of a 2 by 2 matrix, it is a square matrix, 2 by 2, is easy. Say multiplication of the diagonal elements, the A11, A22 minus A12 and A21. But for a 3 by 3 matrix, it is different. So for a 3 by 3 square matrix, we must have knowledge of cofactors and minors. Now shortly it is like this. We'll discuss later on about cofactors and minors. The result will be A11. So first we have to find out the cofactors. The cofactor of A11 is what is the determinant of its minor. Minor means, so delete first row and first column where A11 stands. So A11 stands in first row and first column. So the remaining will be A22, A23, A32, A33. So this is the called the minor of the element A11. So A11 into A22 into A33 minus A223, A32. Okay. So so similarly, we'll have to find out the cofactors of element A12. So delete this row, first row and second column. Rest will be A21, A23, A31, A33. Then determinant of this minor multiplied by A22. Now sign will be determined by there is a particular formula we'll discuss later on when we will discuss cofactor and minors. Now, so this expansion is called Laplace expansion process of a third order determinant. It is the Laplace expansion. So whole thing I have shown here, say A11 into minor, determinant of the minor, minus A12 into determinant of the minor, plus A13 into determinant of the minor. And the sign is determined by its position. If it is odd, if it is even, plus sign. If it is odd, it is minus. Again, even, it is plus. Okay. It can expand with the help of elements of the row or by elements of the column. So it is not necessary that it should be expanded by the elements of the row. Not necessary. It can be expanded by the elements of the column also. Results will be same. Now it is the minor It is obtained by following a definite rule. Suppose A, this is the matrix, determinant of A is equal to 1 into 1491, determinant of this, plus 0, 0 multiplied by this 0, so no need, and plus 3, if we delete this row, this column, it will be 5109. Okay, so this is M11 and this is M13. This is minor 11, minor 13. So determinant of this multiplied by 3, determinant of this multiplied by 1, and so on. So I have shown here. So ultimately, after simplification, the determinant of A will be minus 35. Now rule, first row is selected, take 1, A11, delete the row and the column where it stands, I have already shown. Then take M11, determinant of M11 of the minor, and multiply by the element. Sign is determined. So this is the formula, the minus 1 to the power I plus j into determinant of minor A. Minus 1 I plus j. So suppose it is first element A11. A11 means minus 1 to the power 1 plus 1. So it is even. Then it will be a positive sign. Sign will be determined by this formula. So for example, minus 1 square. So for 1, this is minus 1 square, 1 into minus 35. Then minus 1 to the power 1 plus 3 into 3, 44. So this way the determinant is estimated. So thanks for watching.